top of this unit and the next, like we have the rest of this unit, we have chapter 8 and 1 to do in the new year. So like we're gonna be hustling, which means you got to stay on top of your work. You got to do the assignments. You need to learn how to work quicker. But I am not going to spend any more time reteaching the lessons I've already taught. So if you miss a day, you are supposed to be on Google Classroom. If you come in and go, can you go through this with me? I'm going to say no. It's on Google Classroom. You can watch the video. If you have questions about your assignment, all for it. Okay, I definitely will sit here and help you. But I'm spending, not just in your class, I'm spending a lot of time reteaching because people are absent. Okay, I can't afford to do that. And honestly, it's not really what I'm supposed to be doing. You missed the day, so it's your job to catch up. I will definitely help you, okay, and I will go through the assignment and any questions you have, but I'm not reteaching my notes, okay? You missed that part, so you have to take a little bit of initiative. I've been trying to post more on EDSB. I've been trying to make sure Google Classroom is up to date. Usually Google Classroom is. EDSB, I struggle sometimes to put things, but I've been very like, hey, you have this quiz. This is the assignments that are due with it. The lesson is this is what we went over today. It's on Google Classroom. Like I can only do so much, okay? So if you didn't watch 7.4.1 at home, you might not need to because it is a review. However, we did kind of go over a new method on solving stuff. I don't know which ones you guys like better, but we'll go from there. We need to be able to factor for 7.4 and 7.5. So if we can't factor, then this is really hard to do. What we are doing now is we're going to take our factoring one step further. So last year, all we did was factor, and that was it. This year, we're going to solve what we factor. And it's really easy to do. The tough part still is the factoring part. Okay? I guess one little bit of a review, determining the x-intercepts and determining the y-intercepts. When we are determining the x-intercepts, we set f of x equal to 0, then factor the trinomial, set each factored binomial equal to 0, and solve for x. So this is a new way to get our x-intercepts. So on your worksheet, sometimes they weren't exact, and it was hard for us to tell. This is another way to do it. So let's start with our x-intercepts. That is when y equals 0. Remember, f of x is just another way to write y. Okay, they don't want to write y of x. I don't know why. I think it stands for function of x, if I'm being honest, but it's not a big deal. So I'm going to go 0 equals 2x squared plus 14x plus 12. Now that this is equal to 0, I go, do they have anything in common? Immediately I know that I can divide everything by 2. So I'm going to do that. And I'm left with x squared plus 7x plus 6. Okay, so we just divided everything by 2. Remind me, we need to go back and finish those partial factoring questions from yesterday also. This is what we did yesterday. 2 numbers that multiply to give you the outside, so multiply to give me 6, and add to give me 7. What are those numbers? Shut up, all of you. I saw your faces. I'm not saying it again. 2 numbers that multiply to give me this number, and add to give me this number. What are the... Blank times blank gives me 6. Those same numbers need to add to give me 7. 1 times 6, thank you for being somewhat intelligent and restoring faith in your generation. Because Ryder back there was having, I don't know what he was doing. Okay, so that means my brackets, the 2 is going to stay. The 2 doesn't really matter. Okay, whoa. Jules. Everyone else has figured it out. We get it. The number 6, 7. Haha, so funny. Now I'm moving on. The number 2. We write it there. It does not affect our zeros, but it is technically our A. So that tells us if it opens up or down. Okay? So then I write these x plus 1, x plus 6. Because this equals 0 and these are being multiplied, that means we can set each bracket. So that's where we would have stopped last year. Now we take each bracket and set them to 0. And you're probably going to be able to do this part in your head, which you can. So we take x plus 1 equals 0. We go x plus 6 equals 0. And then we solve for x. So how do I take that positive 1 to the other side? Subtract it. X equals negative 1. Minus 6. X equals negative 6. So those are our two zeros. So when I go to graph that on here, we're going to have one at negative 1 and one at negative 6. So those are our x-intercepts. Pardon? That's all we solved. Okay, so we can use factoring to solve that. Our y-intercept is when we plug in 0 for x, or when we look at that equation, what do we know? What's our y-intercept? 12. Okay, if you couldn't, you would go y equals 2 times 0 squared plus 14 times 0 plus 12. Okay, but remember the c value is always your y-intercept. But we always go back to the original equation. Yeah, that's a good question. Okay, so now we can use something else for making our graphs. Is this your next question? General form. This is just a review of everything. I don't want to spend too much time reading it. Sketch the graph of y equals 2x squared plus 12x plus 10. State the domain and range of the function. So immediately, what can I do? Divide. What can I divide everything by? 2. So I'm going to pull that 2 out in front. X squared plus 6x plus 5. Two numbers that multiply to give me 5 and add to give me 6. X plus 1, x plus 5, correct. Okay, so the faster we can do that, the more we can move on to the actual skill of this unit. We set each to 0, or can you do it in your head? What will x equal? And, okay, so those are our values. So we have one here, and one here. Where will the axis of symmetry be? In the middle of those two. Okay? So this is our axis of symmetry. Right, that imaginary or dotted line. Okay, if we had hard numbers to work with, all we would need to do is negative 1 plus negative 5 divided by 2. That gives me that value. Okay, so if you can't visually pick it up, remember that we're just finding the average or finding the midpoint. If that is my x value for my vertex, how do I find my y? Say that again. So not my y-intercept, but yes, that is my y. So that would be here, which means we also have this dot, right, because they're symmetrical. I'm asking for my y value of my vertex. So let's say we use this formula to find my x value. How did you find your y value on your test for your vertex? Plug it back into the equation. I think that's what you said, right? So I got to go y equals 2 negative 3 squared. I can't remember what it is. Plus 12 times negative 3 plus 10. You don't need to use this because we have our x value already. We used our x-intercepts to find it. If you need to, yes, you can use it. You what? You would have got negative 3. And then you would have just punched this in. This is more concrete. This is like, oh, I understand that they're symmetrical. But you're the one that gave me this answer. Okay, what do you get when you punch that in? Anyone else get that? Yeah, how did you get that? No, like, was that a guess? Yeah, but like, how did you get that right? Okay, so it was a guess. Okay, so now we have, that's a really, did anyone else get negative 8? Yeah, okay. It's just a weird, yeah, like, really steep. Oop. That was bad. That was bad. I know. Whoa, who messed with my board? No, somebody put this down here. I don't know. It should be down there for all the short people. Yeah, it got worse. Okay, so when you're using the x-intercepts, what I'm looking for is the x-intercepts, their matching points, the vertex, the y-intercept, and its reflection point. Okay, because remember that they're symmetrical. So just another way to draw it. That was it, I think, for that question. Oh, state the domain and range, because we need as much practice with it as we can. Domain doesn't change. XER. Range. Y is less than or greater than? Are you sure? Greater than or equal to negative 8. YER. I actually know something over there. Look at you go. New Kingston we got going. He said he was teaching Coco. I don't know if we believe that. I did. Coco, did he? Oh. I would have threw him under the bus and be like, no, he didn't. Okay, this is where it gets a little bit trickier. We are going to write an equation from a graph. That's not your next question, or is it?
We have the sketchy graph of F. This one.
What? That one? Okay. So this would be slightly different in that we can't factor a negative x squared. So all we need to do is divide everything by a negative 1. So I'm going to have that negative 1, and then I'm going to have x squared plus 3x minus 12. So now I'm looking for two numbers that multiply to give me negative 12 and add to give me 3. We pulled out a negative 1 to switch the signs of everything. Is there anything? I don't think there is. Okay, well, we know we can use this then. And we'll go back to the original. So negative 3 all over 2 times negative 1. Negative 3 over 2. And then plug it in to find your y. Negative 3 over 2 squared minus 3 times negative 3 over 2 plus 12. I don't know why I have this question in here if we can't factor it, to be honest. Two numbers multiply negative 12, 1 and 12, 2 and 6, and 3 and 4. Ah, that's why. We have to go back to 7.4.1 and do the partial factoring. Let's go back to the last couple questions, which you wouldn't have filled in. I forgot about partial factoring. And then maybe we'll hit pause after this and we'll finish it up tomorrow. You give a little bit of work time. Okay, so something we didn't talk about yesterday because some were gone. We needed to just focus on reviewing was partial factoring. So we still need to get it into equal 0. So I'm going to take that 26 to the other side by subtracting it. So I'm going to have 4x squared 4x squared minus 26x plus 20 equals 0. So immediately I would go, okay, they can divide everything by 2. When we do that, we're going to have to try to factor, and what we're going to realize is it doesn't work. Okay? When it doesn't work, we can do something that's called partial factoring. And partial factoring is when we put these imaginary brackets around the first 2 terms. Okay? And we just factor those terms. So what do 4x squared minus 26x have in common? 2 and an x. Right? 4 can't go into 26, so we have to go with 2. And that leaves me with 2x minus 13. And then I have this plus 20 equals 0. We're going to pretend that the 20 isn't there, and we're going to solve these brackets. So I'm going to go 2x equals 0, 2x minus 13 equals 0. And we're going to solve those. Pardon? For this? Well, because we pulled out an x, yes. So we had 2 and we took 1 away. Divide by 2, x equals 0. Add 13. 2x equals 13. Divide by 2. X equals 13 over 2. So factoring normally gives us our x-intercepts. Partial factoring gives us the y-intercept and its pair. Okay, so this is going to be the point 0 and 20. And this is going to be the point 13 over 2 and 20. Okay, and I think, in your textbook, it asks you to do partial factoring. I think on maybe your test you have to do partial factoring. So remember that partial factoring gives y-intercept and its, we'll say, reflection point. Okay, so what that looks like is this axis of symmetry and this. So that's what we found doing partial factoring. Usually I'll tell you, like that's why on this other one I should have said use partial factoring, and then that would have sent us down the right path. But now we'll jump back to the question we were on. Who's huffing and puffing? We'll keep this because we can always use it, but so instead of erasing it, we'll keep this, and then we'll do partial factoring just as another kind of point. Anyone have an answer on the calculator for that one? Negative 3 over 2, close your bracket, square it. Minus 3 times negative 3 over 2, that's an ugly 2, but plus 12. Don't even know what it will be. Three over 2 plus what? 18? Anyone else get 18? Okay. Okay, so we have that point. We'll have to do a scale of 2 on our y. I'm going to do a scale of 1 on the x. So negative 1.5. 2, 4, 6, 8, 10, 12, 14, 16, 18. And then we know we have a y-intercept of positive 12. And because we have our vertex, we could find that matching point. Maybe I'm just going to switch it. We have this as our axis of symmetry. So we would have that dot right there. Equal distance from the axis of symmetry. Because we found our vertex first, we didn't have to worry about partial factoring. The only time you're going to have to worry about it is if it asks you to do it, because now we're using a different method for the vertex. And then you would sketch. That's as good as it's going to get. Question? Yeah? So this is our y-intercept, right? And this is 1.5 from the axis of symmetry, which means there's another dot, 1.5 on the other side. Okay. We are going to hit, I think, pause, because I'm losing you. And we'll come back and do this question tomorrow. No, you're going to have a work period tomorrow, and then we have to cover 7.5, which is more factoring. So if you cannot factor, what should you be doing tonight? Factoring. No, not yet.